Okay, class, today we're in lesson 3.2, rate of change and slope. 3.2, rate of change and slope. Essential question, how do you find a rate of change or a slope? How do you find a rate of change or a slope?
You know, rates of change are one of the most important concepts in mathematics. It's going to be with us all through our math career, so it's wonderful to finally think about it for the first time now. Now, to figure out a rate of change, we're going to actually kind of compare how the y's are changing to the x's, and we see how that relationship or that quotient is changing as we go through data. So let's take a look at an example. Here's a table, and I want us to use this table to identify the rate of change. So here are my x values, and these are the corresponding y values. So this is like 0, 1, 1, 3, 4, 9, and so forth down the road. Now, in order to figure out the rate of change, what we do is we see how the x's are changing, we see how the y's are changing, and then we take a look at the ratio or quotient between the change in y over the change in x. So the change in y divided by the change in x. It's that easy. So let's try it together. You'll see it in practice. Now, when I move from 0 to 1, if I hop like this, what kind of increase or decrease do I have? Well, going from 0 to 1, I have an increase of 1. So I'll write a plus 1 here. Now, from 1 to 4, I see an increase of what? Well, if I take 4 and subtract 1, I see 3, so I see a plus 3. When I move from 4 to 5, that's an increase of 1. Again, you can see that by taking 5 and subtracting 4 and seeing 1. So that's a plus 1. And then from 5 to 7, well, that's going to be a plus 2. Great. So that's how my x's are changing. Now let's take a look and see how the corresponding y values are changing. All right. Well, here I go from 1 to 3. So if I go from 1 to 3, that's going to be an increase of 2. So I write a plus 2. From 3 to 9, that's going to be an increase of 6. From 9 to 11, that's going to be an increase of 2. And again, there's lots of ways of seeing that. You could say, 9 plus what equals 11. That's fine. Or you could take 11 and subtract 9. And you'd see 2 in both cases. And what about here? If I go from 11 to 15, what kind of change is that? Well, that's an increase of 4. So plus 4. Okay, so now I have all these values. What do I do with them? Well, we've got to think. We're looking for rates of change. We want to compare the change of the y's to the change in the x's by actually dividing. So let's check this out. If we take a look at the ratio between y and x here, what do I see? Well, I see 2 over the corresponding change is 1. So this equals 2. Here I see 6. And the corresponding change is 3. So I have 6 over 3, which if I simplify, I again get 2. This is kind of cool, isn't it? Neat that there seems to be 2 in these cases. Now let's see that continues. Here I see the change in y is 2. And the change in x, corresponding change, is 1. And 2 over 1 simplifies to be 2. And if I take 4, that's the change in y, and the corresponding change in x is 2. If I simplify 4 divided by 2, I see 2. Notice I see 2, 2, 2, 2. It's constant, so we see the rate of change here is constant. This has constant rate of change. Okay, let's try another example. Now here's a different table of figures, and let's see what happens here. Well, let's look for the changes in the x's and then the changes in the corresponding y's. To go from 0 to 2, that's a change of plus 2. When I go from 2 to 3, 3 minus 2 is 1, so that's a change of plus 1. 5 minus 3, that's a change of plus 2. And 8 minus 5, that's a change of plus 3. You see how I got those values by taking the 8, subtracting the 5, and so forth down the line. Let's see what the corresponding change in the y values are. Okay, now this is going to be a little tricky, so let's think about this. To go from negative 1 to 3, that's 3 minus negative 1. Well, 3 minus negative 1 is the same thing as 3 which is actually 4. So in fact, the change here is 4. And if you think about it, that's right. If you take negative 1 and you add 4, you do get 3. So this actually is okay. Now what about here? This will be easy. I take 6 and subtract 3. That's going to be an increase of 3. Here I take 12 and subtract 6, and so I get plus 6. And then finally, to go from 12 to 15, 15 minus 12 is going to be plus 3. So I get those changes. Now, to take a look at the rate of change, we look at the ratio of the change in the y values to the change in the x values. So this is the important feature here. So let's take a look at the rate of the first change here. So I have 4, and I'm going to divide it by 2. So plus 4 divided positive 4 divided by positive 2, which if we simplify that, we just get the number 2. Okay, great. Let's look at the next changes. In the y, we see 3. In the x's, we see 1. And that simplifies to just 3, which notice is actually different. So we can see immediately this is not going to have a constant rate of change. This will be a varying rate of change. But let's keep going and see what happens here. So if we compute this ratio, that would be 6 divided by 2. 6 divided by 2 actually equals 3. So here these are the same values. And then finally, the last one, we see the y change is 3, and the corresponding x change is 3. 3 over 3 is 1. And so we see the rates of change here. This is going to be 2, 3, 3, 1. Notice since they're not all the same, we say that, in fact, this is not a constant rate of change, but, in fact, variable rate of change. And we can measure that rate.
Remember that the rate of change of a function is a ratio that compares the difference between two output values to the difference between two input values. So in essence then, rate of change is equal to the change in the y values divided by the change in the x values.